I mean, I thought yesterday we could have had a 2-hour delay. So chapter 5 is called Analytic Trigonometry, and basically we are going to take trig and algebra and mix them together. So instead of just talking about trig functions and graphing trig functions, we're going to talk about solving trig equations and factoring with trig stuff and proving trig identities. Pretty exciting stuff. So not going to lie, I kind of like this stuff because I love factoring. I love trig. Oh my gosh, it's both together. But you got it right, Stan.
What's the U?
Just U, just instead of theta. I was prepared to print these out if we had a 2-hour delay, but we didn't have a 2-hour delay, so we can write. We do have try time today, though. Today, but not Thursday. I know. Because I-step doesn't start till tomorrow, but they have I-step tomorrow and Thursday and Friday, so no try time Thursday. Okay, we wrote these out at the beginning of the last chapter, but maybe you forget, so we're going to write them out again. These are the identities that you need to know, that you need to memorize. At some point in this chapter, we will get to identities that I'll give you on the test. You just have to know how to use them. But until that day comes, everything I give you, you need to memorize. These you should already have memorized. All the reciprocal identities, you know those already. The reciprocal of sine is cosecant. So if you have sine of anything, they use u instead of x, because u could be anything, then that would be just 1 over cosecant of whatever u is. Right? Cosine of u, we know is equal to 1 over secant of u. Those are reciprocals. And tangent of u is equal to 1 over cotangent of u. So that could be theta. That could be 2 theta. Tangent of 2 theta is equal to 1 over cotangent of 2 theta. So it doesn't matter what's there. You can just change it to the reciprocals. And so then I just put the ones right here with it. So cotangent of u would be 1 over tangent of u. Secant of u would be 1 over cosine of u. And cosecant of u would be 1 over sine of u. They call these the fundamental identities because they're really what all the other identities are based around. And again, I hope that those you kind of know already. You don't feel like you need to make flashcards to memorize those, but good. Jake Berg has opened my eyes to this lovely thing called Quizlet that you can make your own flashcards on and you can study them. He does it for his vocab in English and he has them all pre-made. We made one of these for my Math 137 class because they're taking a test over this stuff this week. And I can copy that and share a link with you. And then if you can go on your computer or you can download the free app, and then I'll have done all the hard work for you and made the flashcards of all these identities, and then you can practice them. So it's kind of nice. Instead of actually having to carry flashcards with you, if you have your phone with you, you can just slide through them and flip them over. And it's kind of, I like to study with flashcards, but maybe that's just something. You use Quizlet?
Yeah, someone like me.
Made them already? Yeah, and there's most of the math ones are made already too. Like we could probably look up trig identities and there would be pre-made ones already for us. But it's kind of a cool thing. Instead of having to actually use paper flashcards. Remember that we can also write tangent and cotangent in terms of sines and cosines. So since tangent is y over x, and y is sine, and the cosine is x, we can say tangent of u is the same as saying, that's not really n, I combined my n and my u. Sine of u over cosine of u, so cotangent would be cosine of u over sine of u. And also, that first day of 4-4, day 1, seems like a long, long time ago, I gave you these Pythagorean identities, and they're called the Pythagorean identities because they're all based on the Pythagorean theorem, and that we could prove them setting up a triangle, Pythagorean theorem. But you just need to memorize them. You don't have to know the proofs of them, but these are the ones probably of these first ones today that I'm going to give you. These are the ones that you don't know off the top of your head, that you need to memorize these. And remember that when we square a trig function, we put the square next to the trig function. So this sine squared u would be like taking the sine of u and then squaring it, but instead of having to put parentheses around it, we just put the square next to the trig function. But that's what that means. Sine squared u plus cosine squared u will always equal 1. 1 plus tangent squared of u equals secant squared of u. And 1 plus cotangent squared of u equals cosecant squared u. Because I'm showing u, I'm showing that u can be anything, right? It doesn't have to just be theta, it doesn't have to be x. U can be anything you want to be. Also, be aware that these are equations. So although I memorized sine squared plus cosine squared equals 1, is that the same as if I would say cosine squared equals 1 minus sine squared? Are those equivalent? Because I can add and subtract things in an equation. Yes? Yes. So just be aware that these might show up and look different, but if you know the basic ones, then you can do the algebra to move things around. Okay? So what are we going to do today? Part of what's on your homework today is not new. They're going to ask you, given one trig function, to find the others, and we could use some identities, or we could just draw a triangle. But then the other part of today, we're going to start simplifying trig functions, doing some algebra. So, is everybody okay with this? Stop me if I go too fast. I'm so excited to teach you. Oh my gosh, I forgot about these. Bar.
I'm so excited.
Oh, I'm not excited for these.
Give them a minute.
No, you need to know them. I'm going to put pi halves in all these. Wouldn't have been so nice if I printed these out for you. I think you learn better when you write. That's why I don't print them out for you. I learn better when I write.
See, that's
I know, I'm imposing the way I learn on you.
we learn better.
Okay, let's do a ratio of how many times I print notes out and how many times I don't print notes out. I'm pretty sure like 80% of the time I print notes out.
80% of the time for the last chapter, you learn notes out. The rest of the year,
Just saying.
start here early.
The trig. These are called the cofunction identities. Again, I'm pretty sure I printed these out for you for day 1, that you have them somewhere. But you need to know that complementary angles, cofunctions that are complementary angles will always be equal. And so this is like the identity way of writing it. This could also say 90 degrees minus u. But that's just saying that sine and cosine are cofunctions. Tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. So that's why these just change places, right? As we go through these, like these go together, these go together, these go together. Identity-wise, you need to know them, because if you see sine of pi halves minus something, you want to be able to replace that with cosine of the angle, because you'll be able to solve it easier. But what that's saying is that if two angles add up to 90 degrees, then their cofunctions will be equal to each other. So, like, we know this already. Cosine of 30 degrees equals sine of 60 degrees. Why? Because they add up to 90 degrees. Or pi halves, we could say cosine of pi 6 equals sine of pi thirds. And that works with any of these cofunctions. Secant of, I don't know, let's stick with degrees, it's easier. Secant of 15 degrees is not a pretty number, but I can tell you, because secant and cosecant are reciprocals, that secant of 15 degrees would equal cosecant of 75 degrees, because they add up to 90 degrees. That's what that all says. You're going to see as we do these identities and these proofs, you don't really need to know the number part, you need to just know what you can fill in. And we've also talked about even and odd functions. On your last test, I gave you that question wanting you to talk about that sign was odd. But again, talking about algebra-wise, if you want to be able to replace stuff, every function except for cosine and its reciprocal secant are odd functions. What does that mean? By definition, an odd function means that when you plug a negative in, you get back the opposite of the function. Right? So when I plug in a negative x, the whole function becomes negative. That's what all of this is saying. If you take the sine, cosecant, tangent, or cotangent of some negative angle, it will be the opposite of the trig function of that positive angle. And then these are even functions. By definition, if you plug in a negative number into an even function, nothing happens. You get back the same value. That's why cosine is the same on both sides of the y-axis, and all the other ones are opposite. because cosine is even. And again, I'll show you as we do some of these how this is going to come into play in chapter 5. Okay, I really promise that it's examples after this. I just forgot this page. Everybody done with this? Here we go. I'm going. Again, this is not anything new. We've been doing this for a long time. Use the given values to evaluate the remaining trig functions, which means you can just draw a picture and label the sides of the triangle and find the missing sides. But I just wanted to refresh your memories. Big gross mess out there soon.
Yeah, we should probably leave early.
It's gonna rain and it's just gonna be.
It's supposed to freeze. It didn't freeze last time.
But then tomorrow it's supposed to get a 20, so it's supposed to start turn back to snow tomorrow. And then like Thursday the low is -2. So yay! Weather like this in Italy.
Even though it's snow is good where you get in America. Maybe it's not. Somebody thinks
Right, if they give me secant of x equals 4, do you agree that right away I can say cosine of x equals 1/4? Yes? Like that's a free one that you should know. They tell us that sine is greater than 0. Why do they tell me that? Because you got to figure out what quadrant you're in. If secant's positive, cosine's positive, and sine's positive, what quadrant is the only quadrant where sine and cosine are both positive? Quadrant 1. So that's why they give you this. If it would have said sine is negative, then that changes it. Now we're in quadrant 4, so pay attention to it. So I'm going to draw a lovely picture over here in quadrant 4. They call the angle x, so I'm going to call the angle x 1. I wrote the right thing. And cosine is 1/4. Do you agree I could label my triangle like that?
Yes.
Good old SOHCAHTOA. Solve for the missing side. Yes?
Yeah.
So that would be 16 equals 1 plus something squared. So 15 equals b squared. So that equals the square root of 15. I hope Pythagorean theorem is like, 2 plus 2 for you these days. In my class last night, we did this problem on the board, which I can't even begin to explain to you. But they got these answers, and this kid was so excited in the front row. He's like, oh, it's 02000, and the next one is 03040, and then they're all like, oh yeah, that makes perfect sense. And then this other kid was like, oh, I finally get it. And I was like, this is not how I did these problems. Like, did I do all the problems wrong? So I sit there and I'm like working stuff out, and they're moving on, and I was like, okay, wait a minute. You need to explain something to me. So I like asked this whole definition. I was like, I think it's supposed to equal 0, and that doesn't equal 0. So then they're like, oh yeah, that's wrong. And they just moved on. Like the teacher just let them be wrong, and no one. No, I was right, but they were wrong, and they all convinced themselves that it was the right way to do it, and it was so easy, and it finally made sense, and it was the wrong way to do it. So then we had to fix it. And he was like, oh yeah, we did that wrong, and so we went back and fixed it. The kid that said he was right to begin with was like, I was just making crap up, only he didn't say crap. So
Did you start crying?
no, he just laughed because he did it all wrong.
What did he say if he didn't say crap?
The other word for crap, that's a bad word.
Yeah.
Not poop. The other word. Right? If you draw your triangle and you label it right, you just fill it all in, right? We should I hope feel good about this. So sine is square root of 15 over 4. So that would make cosecant 4 over the square root of 15. And again, I don't make you rationalize that, but just make sure you're aware that you know that that's the same as this. Right? If I ever wrote something like this as like a multiple choice question, I would hope you could match that up easily. But I would count either one of those, right? And tangent would just be square root of 15 which would make cotangent 1 over the square root of 15, or square root of 15 over 15. Hopefully just a nice refresher of your favorite SOHCAHTOA stuff. Never. Oh, I started telling that story because I said, isn't that supposed to equal 0? And it doesn't. It equals 2 plus 2. And the kid in front of me said, doesn't 2 plus 2 equal 0? And laughed because he was joking because I thought I was wrong, and so I was trying to get them to explain to me what I was doing wrong. And I was like, I thought it was supposed to equal 0, and it equals 2 plus 2. And he was like, isn't 2 plus 2 equal 0?
So it sounded like?
Yeah.
Are these like college-age kids using this classroom?
Yeah, yeah. Like 19, 20-year-olds.
Oh, it's true, like
No, there's a kid next to me, there's a guy next to me that's like 50.
Do they think that like you're annoying when you tell them that?
No, and there's 2 girls next to me, I don't know how old they are, but they have kids. I don't
That doesn't mean anything.
It doesn't mean anything.
They're like,
But I'm just saying, like, they seem adult-like to me. And then there's a guy that has a curly mustache. I always want to take a picture of it to show you. Because he has a mustache and it, like, curls out on both sides. And I think, really, like, that's amazing that that's your mustache for real life. Like, real life, that's your mustache. It's awesome. It's just I've never seen someone that has a mustache like that.
There's this guy that
And so he's older, but he's an undergrad still, so.
white glasses, and like a white beard, looks like Santa. At this Chili's up there that went to Iraq on Friday, and he had a red jacket and a red hat on, and I was like, oh, well, I don't want to offend him by saying anything. I see him 2 days later at Walmart,
Just
same
a
red
Santa.
jacket, red hat.
Okay. I think this is just a weird font data, so don't be freaked out by this. Also, be aware in this chapter they like to use lots of different Greek symbols, so just practice drawing them. No big deal.
Wait, what is that?
I think it's just a bad theta. Like it's just a bad font. Simplify. Simplify probably means like distribute, multiply, combine anything you can combine. So when I see parentheses, even though they're trig functions, I'm going to simplify. And I'm going to show a lot of work on this, but eventually you're going to do this pretty quickly in your head. But if I distribute here, that would be sine of theta times cosecant of theta minus, what would I get if I took sine of theta times sine of theta? Sine squared theta, just like x times x gives me x squared. So I'm going to write that as sine squared theta. Yes?
This is a little off topic. It's about distributing. When did we stop doing order of operations and start distributing? Because I was tutoring the kids for ISTEP, and they were doing order of operations, and I was like, no, like this is wrong. So why wouldn't we do the parentheses first? Oh, whenever it's
Right? Like,
got it.
when there's numbers, it doesn't matter. You can distribute or you can do order of operations, you'll get the same answer. You can't take x minus 3, so that's why we distribute. Okay? I can answer that question. So now the question is, can we simplify anything else? Can we simplify sine of theta times cosecant of theta? Could I rewrite cosecant of theta any way? What happens when I take sine of theta times 1 over sine of theta? Does it make sense if I take a function times its reciprocal that I should always get 1 back? If it doesn't make sense, just simplify, like write them in the same term. And I could say this is 1 minus sine squared theta. I don't know, is that my answer? Can we do anything else? Do we have any trig identities that have a sine squared in it and a 1 in it? Oh, we do! It's a Pythagorean identity. So let's think about our Pythagorean identity. It says sine squared u plus cosine squared u equals 1. What would 1 minus sine squared theta equal? So this is the same as cosine squared theta. Because we're getting to the point of solving equations. Today we're just practicing, so it seems like we're doing it just for fun. But we'll get there. Not always, but a lot of these you end up with 1 trig function. So that's kind of not necessarily always the goal, but you want to try to simplify it as much as you can. The nice thing about odd questions is you can check in the back of the book. If you would have got this, if you check in the back of the book to solve this, hopefully it kind of gives you that push to get there. I like the proofs better because it tells you what you're supposed to get, and so you have like a direction to go in. But we'll see. Let's do this one. Whoa. So this is today, I think, is one, just practicing doing the algebra with the trig functions. Boy, stop. And two, it's to get you comfortable with all these identities. So when I see cotangent of pi halves minus x, I think, oh, I think I just wrote an identity out that said that, right? So look back in your notes and tell me, what does cotangent of pi halves minus x always equal? Tangent of x. That's why you need to know those identities, because we can't do anything with these two trig functions if they're not the same thing, right? If they're not both x or both u or whatever. So you need to change that to using that identity of just saying that's the same as saying tangent of x times cosine of x. Now what could we do? Move on to the next problem?
Yes.
Could I rewrite tangent as sine of x over cosine of x?
And I guess it's because of sine of x.
Oh my gosh! That's the same as just saying sine of x. I think I like this also because I love crossing things out. It makes me feel like I've accomplished something in my life when I can cancel something out.
It's not like a
How did I know to plug in sine over cosine and not 1 over cotangent? Well, because there was a cosine there. So look what's around there to think about, could I rewrite that to cancel something out? And that's the hard part, is I can't tell you every time what to do. You have to just know the different strategies to look for, and that's why people don't like this. Ooh, how about this one? The directions say factor and simplify.
letters in a row.
There's too many letters in there.
I can see it. Like it's like just
Too much. Put a space in there if you'd like.
or parentheses.
Or a parenthesis. I don't know. So today they're trying to give you hints on how to do it, right? So it says factor first. So they're telling you, look at that, and you don't necessarily have to factor first on this, but we're going to. What could I factor out of both of those terms? There is a sine squared in both of them. So just like you can take a 4 out of both terms, or you can take an x squared out of both terms, I can take a sine squared and then write what's left over, like undoing the distributive property. And if I take a sine squared out of this, do you agree that I'm left with cosecant squared x minus, what happens when I take sine squared out of sine squared? I'm left with 0, 1, because we're dividing. You guys are smart. My ECA kids always say 0. Next question. Can I use a Pythagorean identity to replace this? So let's go back and tell me what's the Pythagorean identity that has cosecant squared in it.
Well, wait a second. 1 plus cotangent.
Right? 1 plus cotangent squared equals cosecant squared. So if I subtract the 1 over, does that equal cotangent squared? You see how I can make that match what's up here?
You have to like it. It's almost 100%.
And so now this is where we have to expand our identities a little bit. The only identities that we have that are squared are the Pythagorean ones. But all the other trig functions, identities that I gave you, you can just square it and it works out the same. So I told you that cotangent squared equals cosine x over sine x. It's an equation. If I just square both sides, is that still equivalent? Yeah, so I see that if I had a sine squared on the bottom, I could cancel that with that sine squared. So I'm going to replace cotangent with cosine squared over sine squared. And so you're allowed to do that if you just square everything. It's an equation, so you can do that.
Putting equal signs there.
Yeah, don't put equal signs. So what does this simplify out to be? Just cosine squared. Oh man.
It's just like pretty much quadratic.
It is a quadratic! With trig!
She's so happy. That misery.
I lost my coffee cup this morning, but then I realized I think I left it in my car.
Man,
I have 2 every day.
that's too much. Oh my god.
So, Grady saw right away that this is a quadratic. We have something to a power, and then this is half of that power, and then a constant at the end. So you could kind of think about this as like x to the 4th plus 2x squared plus 1. But instead of x, it's really tangent x. Do you see that? So this is where you have a choice. You could do u substitution. Remember doing u substitution last year? Or you could just kind of work out, instead of doing the u, you could just put the numbers in there. So I'll do u substitution on this, and then we'll talk about if you don't like u. I don't like u most of the time, so it's always fun to say that. Do you know what year u would be in this?
Tangent squared.
Yeah, it has to be, it's always whatever that middle term is, because then you want to write this as u squared. So since this is tangent squared, our u would be tangent squared x. So we want it to fit that lovely quadratic of ax squared plus bx plus c. So if we made this our u, then this would be u squared, right? Because tangent squared times tangent squared. So u squared plus 2u plus 1. You don't like the u, or you don't like it all? At all. If you substitute the u correctly, it's pretty easy to factor. What multiplies to give me 1 that adds to give me 2? Plus 1 plus 1. 1 plus 1 equals 2, not 0 or 5. Don't forget that u substitution is just like an in-between step to help you. Like, this is not your answer. You always have to go back and plug in what u is. So that would be the same as saying tangent squared x plus 1. And since there's 2 of them, can I do like that? Are you okay if I do that? Since there's 2 of these, like that's like u plus 1 squared. You don't have to do that. You could write 2 of them. Anytime you see a squared trig function, look at those Pythagorean identities. Does tangent squared x plus 1 equal anything? 1 plus tangent squared equals secant squared x. And really it's like secant squared x twice. So could I just say that's secant to the 4th x? Oh my gosh.
You just say it's secant squared x squared.
Secant, if you put the parenthesis there, right? So here's why it's important to write your exponents here or to use parentheses. Because if you just wrote this, am I going to count that right? No, because that looks like the x's squared, not the trig function. So as long as you put parentheses like that, I would count it right. This is a better answer, but I mean, that's the same thing. You just didn't distribute your exponent. If you don't like you,
I can't stand you.
I know, I can't stand you either. You can always just, like, the u is just to help you make it look better, but you can always say, like, what multiplies to give me tangent to the 4th? It's tangent squared and tangent squared, right? So if you can just think about what goes there, you don't have to use a u, but it's okay to use u also. Yeah? Let's do some more. It's like never-ending problems today. So now instead of factoring, now they want us to multiply. It never ends. Foil?
Well, like good night.
We can't because they're not squared yet, right?
Make rational answer.
Right, so you can only do the Pythagorean identities when they're squared. So Olivera was pointing out that cotangent and cosecant are together in the Pythagorean identity, but they're not squared yet. So when we FOIL them,
Don't you go make logic lessons now.
cotangent times cotangent is cotangent squared. Cotangent times negative cosecant would be negative cotangent x cosecant x. Cosecant times cotangent is plus cotangent x cosecant x. Should have written smaller. Look at this awesome power I have. And then cosecant times negative cosecant is negative cosecant squared x. Maybe you noticed, to begin with, this was the same thing in both parentheses. One was a plus, one was a minus. So does it make sense that those middle terms are going to cancel out? Well, multiply it out on your paper. Like, you shouldn't need to just copy what I have. You should be able to multiply. Cotangent times negative cosecant is negative cotangent x cosecant x.
But I want to do the whole thing. I don't want to skip a step.
Cosecant times cotangent is cosecant x cosecant x. Exactly. A plus b times a minus b will always just equal a squared minus b squared. So when it's the same thing in both parentheses, whether it's trig functions or numbers or letters, that middle term should always cancel out. So you're left with cotangent squared x minus cosecant squared x. Now they're squared. Now you can look at your Pythagorean identities and tell me if that equals something. 1 plus cotangent equals cosecant. Is that what the formula is? So let's think about how we could make that match up, right? I always call this my side work or my brain work if I can't just look at it and see. If I want to subtract this over, right, I could say cotangent squared x minus cosecant squared x, but then I'd want to move that over there. So would that make that equal -1?
So the whole thing is -1.
The whole thing is just -1. So the next time you want to write -1 as your answer, you could just write this if you wanted.
Okay, I mean,
You could. I'd have to count it, right?
So every time that we do like FOIL something like that, is it just getting
Only if it's the same thing in both parentheses. One's a positive, one's a negative. Okay? That's awesome, right? That's like, isn't that cool? My husband gets very annoyed at stuff like this when he was in algebra. He was like, all that work and it's just -1 or 0. He really hates when it's 0. And I think it's cool. All that work and it's -1. That's why I'm a math teacher and he's not. You do this one. What time do we get out of here? 55? Thanks.
I think my day would be a lot better if I was getting like now.
I think how much you would be able to learn.
I'll learn. You still would have learned, just not
No.
today.
You're missing out on learning every time
You're
you
saying
start
you wouldn't have taught it.
Let's do this problem. I think I would have went a lot faster and you wouldn't have understood it. Or do you have your own comments to add after every problem? Do this. You're not.
Have it written down.
How about that last problem about the pizza on the, let's say that's pretty awesome, right? On the pizza. Let's talk about pizza. Not that in the little
Oh, the first part.
Yeah, that was, I think everybody was sick.
Really?
Maybe, yeah.
What was the answer?
I don't remember, but I don't think it's right.
Oh, dang it.
It's the hard one. It's the hard one of the test.
does it do minus?
Oh. If you notice that it's a difference of 2 squares, you don't have to do the middle part, right? I'm just showing my work, but these two should cancel. So we get 9 minus 9 sine squared x. My Pythagorean identity doesn't have 9 in it, it only has 1 in it. So what could I do? Could I just factor a 9 out? And then again, that's where hopefully almost all of these problems have used the Pythagorean identities. So after you do the homework today, hopefully you'll pretty much have those 3 identities memorized because those are the newest ones, the hardest ones I think so far. But remember that sine squared plus cosine squared equals 1. So 1 minus sine squared would equal cosine squared x. Can't do anything with it. just make it disappear. The nice thing about today's homework is it gives you directions on what to do. So let's see if we have more. I don't remember. Hopefully not. Oh, look at all these problems stuff. How quickly we did 7 problems though. With me talking about them.
Wow.